The final set of organizational principles is actually one principle, but it is divided into three sub-principles. It's all about minimality. The agile approach wants you to produce as little software as you can in order to produce what you do produce right. And minimality or minimalism has three aspects which are distinct. Produce minimal functionality, 5.1, produce only the product requested, 5.2, and develop only code and test. So the first is about developing minimal software. There's a principle which was introduced, I believe, by extreme programming and which is commonly referred to in the agile world. It goes by the slogan YAGNI for you ain't gonna need it. That is to say, before you build a certain functionality into your system, make sure that someone somewhere really is going to need it. So here's what Ron Jeffries has to say. This principle, the YAGNI principle, reminds us always to work on the story we have, not something we think we are going to need, even if we know we are going to need it, which is perhaps a bit extreme. When he uses the word story, he is referring to something that we're going to study in more detail, the notion of user story, which is the unit of functionality and also the unit of requirements. And so what he's saying is you get stories from users and don't try to do more than what the users have requested. They are going to give you individual stories, meaning individual pieces of functionality, and don't try to be too general. Here's another view on the same topic by Mary Poppendieck. Our software systems contain far more features than are ever going to be used. So she's criticizing many existing systems. Extra features increase the complexity of the code, driving up costs non-linearly. If even half of our code is unnecessary, a conservative estimate, the cost is not just double, it's perhaps 10 times more expensive than it needs to be. So there, as always, there's a grain of truth here, and certainly we have all grappled with software systems that we think have far too many functionalities, including things that we are never going to need. And when we are never going to need them, it's easy to conclude that no one's going to need them. But of course, the reality is usually more complex than that. If a functionality is there in a software system, it's not just because some crazy programmer has decided to put it in, but usually it's because some customer, some perhaps big money paying customer wants it. So it's easy, of course, to dismiss systems as being too complex and having too many functionalities, but your useless bell and glitch may be my essential functionality. So these things are not, this kind of criticism is partly founded. Of course, it is true that people sometimes build in too much functionality, but there is only so much you can do to remove functionality. And of course, the quantitative elements in this criticism non-linearly, if even half of our code is a necessary conservative estimate, it's perhaps 10 times more expensive than it needs to be. All this is very informal. I don't know of any studies that actually back these claims. So this is the kind of agile advice that it doesn't really go very far and should be taken with a grain of salt. So in fact, if you're listening to Mary and Tom Poppendieck, it's more interesting to look at their definition of waste, because this is much more constructive and practical. So in the lean approach, as we have already noted, there's an emphasis on avoiding waste. And this comes from industrial engineering. As I mentioned, it's from car production initially, and it's transposed here to software. So she talks about 7 wastes of software development and gives examples for software. And it's actually quite interesting to look at this list because it gives us some practical things to look out for, a checklist of things to check. And it's true that many software projects sin in some or sometimes all of these dimensions. So extra unused features, that's overproduction in classical industrial engineering. So don't build in any features that you're not sure someone somewhere is going to need. Partially developed work which is not released. In in classical industrial engineering, this corresponds, of course, to inventory, which people try to minimize. And in software, it's anything that the programmer tells you excitedly about. It's being developed, but it's almost done in the famous sense of almost in software engineering, and it's never going to be released. Well, this is waste. Intermediate unused artifacts, so things that were, for example, preprocessors or various tools that have been built in order to help the project, but in fact do not help it and just take time away. Seeking information. In industrial engineering, this would be motion. Too much time and money spent on moving products around, and Poppendick's analogy for this in software is information that we don't have. We cannot do something because we are missing information about the customer needs, or we're missing information about algorithmic techniques, and we waste time because of that. Escape defects not caused by a test review. So in general, it's defects, and of course defects are very costly. Waiting, including waiting for customers to tell us what they need or to give us some critical information about the business. And finally, handoffs. We've also encountered the term handover. It's the same thing. So in industrial engineering, it would be transportation, money and time lost by moving products or materials from plant to plant. In software, it's any time there are several notations and tools used to work on the same thing. For example, an analysis and design notation like UML, and then a programming language where you have to do translations and communication between various formalisms. It's much better to work in a single framework if you can. So this checklist of sources of waste to look for is a very useful contribution of the lean approach. The second aspect of minimalism is to build a product only. And this is a reaction against too much pressure to build extendable software, that is to say software that will be changeable for new purposes, new requirements, and also to build reusable software. So here's a text by Ward Cunningham, one of the very top names in Agile, in particular in extreme programming, which talks about this. You're always taught to do as much as you can, and he means, of course, in traditional software engineering. Always put checks in. Always look for exceptions. Always handle the most general case. Always give the user the best advice. Always print a meaningful error message. Always this, always that. You have so many things in the background that you're supposed to do, there is no room left to think. I say forget all that and ask yourself, what's the simplest thing that could possibly work? This last sentence, what's the simplest thing that could possibly work, is also a well-known Agile and particularly extreme programming slogan. Well, this is really exaggerated. Of course, it's hard to criticize Ward Cunningham, who has many achievements to his name, in particular the invention of the wiki, but he is really going too far here, and he is denying the effects of 40, 50 years of software engineering and good software development practice. And indeed, the difference between good engineers and bad is partly that a good engineer is going to look beyond the immediate goals, beyond the immediate requirements that he or she has been given, and instead try to build a product that's going to stand the test of time and the test of change. So this kind of advice really is somewhat Luddite and is best disregarded. And same thing about reuse. Here is another top name in extreme programming, Ron Jeffries. So basically what I'll let you read the details of the text, but what he's telling you is that he doesn't try to do more than what he's asked to do, and it's a waste of time most of the time to think about possible reuse. Just do what you're asked to do. And of course, this is not what good engineering is about, in particular good software engineering. And in good software engineering, we try to think of not just today's project, but the next project. Now, as always, there's a grain of truth. It's true that some programmers may indulge in too much perfectionism and see the long term at the expense of the short term. In the short term, we have a product to deliver, but of course, good software engineering means that you build stuff that is going to be useful again for your next project and the one after that. And really, this kind of advice is best ignored. There's a third aspect to minimalism. It's the emphasis on building only code and tests. So in a somewhat extreme view of agile methods, but it's really what most agilists recommend, all that really matters and all that you should build is code and tests. So Coburn, Alistair Coburn writes, you get no credit for any item that does not result in running tested code. And then, as I pointed out, he's somewhat more moderate than some of the other agilists, so he adds as a qualification, okay, you also get credit for final deliverables such as training materials and delivery documentation. Well, thanks for the permission, but my customers would probably be very upset at me if I did not deliver training materials and everything that they expect for practical use of the system. Poppendiek, the documents, diagrams, and models. Maybe I should use a different tone to read this because it's things she doesn't like. The documents, the diagrams, the models produced as part of a software development project are often consumables. This is also a negative word, right? Are often just consumables, aids used to produce the system, but not necessarily a part of the final product. Once a working system is delivered, the user may care little about the intermediate consumables. Well, sure, but this is true of any engineering, right? If you are working over a bridge, you're a user of the bridge, and you certainly don't pay much attention. You care little about the plans and diagrams that were used by the bridge builders. On the other hand, it doesn't mean they were useless. So again, this kind of advice saying reject any intermediate product, just focus on code and tests, has a grain of truth. It is true that people and projects sometimes pay too much attention to intermediate products, but in the end, you do need, like in any good engineering, plans and documents and diagrams. Otherwise, you're not going to get very solid results. So what we've seen in this segment is the agile insistence on minimality in three ways: minimal functionality, build a product only, today's product only, not tomorrow's, and only code and test. And we have also seen that there is the criticism of approaches that put too much emphasis on plans and intermediate documents. Is the criticism is partly justified, but it really goes too far, and these are not the best parts of agile methods. We should not heed some of the more extreme advice, and we should practice good engineering.